Prove the identities. Cos 2 theta equals to 1 minus tan theta squared all over 1 plus tan theta squared. Then Roman 2, 1 minus cos 2 theta all over sin theta equals to tan theta. Solution, we start with the first one. We shall prove the right hand side. We shall prove the right hand side that this is the same as that. So we have 1 minus tan theta squared all over 1 plus tan theta squared. We know that tan theta equals to sin theta over cos theta. Tan theta equals to sin theta over cos theta. Therefore, this one will be equal to 1 minus, so this will be sin theta squared all over cos theta squared all over. Now this will be 1 plus sin theta squared all over cos theta squared. Now we can deal with the numerator here. Deal with the numerator first. So we have the LCM here will be 1. The LCM will be cos theta squared. Of course, this is over 1. So we have 1 cos here, cos theta squared times 1. We have cos theta squared minus this cos here 1 times that. So we have sin theta squared. So this is the numerator. Then for the denominator, we do the same. For the denominator again, the LCM will be cos theta squared. 1 cos here, how many cos there? Cos theta squared. Then cos there 1, so plus sin theta squared. So therefore the 2, this equation will be equal to, now we have this, which is cos theta squared minus sin all over cos theta squared, then divide by now this one, which is cos theta squared plus sin all over cos theta squared. All over cos theta squared. Now, so we can write this one as cos minus sin over cos times, we get the reciprocal of that, times cos all over cos theta squared plus sin theta squared. So this and this will cancel, and then we know this, the fundamental identity, cos theta squared plus sin theta squared is equals to, this one equals to 1. Therefore we have cos theta squared minus sin theta squared, which equals to cos 2 theta. We have proved cos theta squared minus sin theta squared is equals to cos 2 theta. So move on to Roman 2. Roman 2, we can prove the left hand side. Prove it left hand side. We have 1 minus cos 2 theta can be written as cos theta squared minus sin theta squared, then all over so sin 2 theta is the same as 2 sin theta cos theta. Now we can write cos theta in terms of sin theta, applying the fundamental identity where we know that cos theta squared plus sin theta squared equals to 1. Therefore, cos theta squared will be equal to 1 minus sin theta squared minus sin theta squared. So therefore, this will be equal to 1 minus. So we replace this by this, so you can minus into. So this will be 1 minus sin theta squared minus sin theta squared, then all over 2 sin theta cos theta. Now when you remove the bracket, minus 1 and 1 will cancel because positive 1 minus 1 it cancels, but then this now will be positive because of this negative side, so we shall have 2 sin theta squared all over 2 sin theta cos theta. 2 and 2 will cancel out, so 1 sin will cancel with the power there, so that will remain sin theta all over cos theta, which equals to tan theta. We have proved the identity. Thank you for watching and listening.